My same friend who wants to learn coding also wants to learn discrete maths. Don't worry, Kanbu, I've got you. I'm going to get you through your degree. Once maths gets beyond a certain level, it starts to split into specializations. Discrete maths deals with a lot of fundamental logic and proofs. Admittedly, this doesn't narrow things down much. Discrete math courses are often included in computer science programs. Back in the day, when I was studying my first degree, my university made discrete math compulsory for multimedia students. This was an absolute bloodbath. The fundamental building blocks of logic are three operations: and, or, and not. Let's start with or, and demonstrate how this works by building a truth table. To model the statement A or B, write out a table which describes all possible states for A and B. Here 1 stands for true and 0 stands for false. Now the statement A or B is saying, is A or B true? This is false if both A and B are false, but otherwise it's completely true. This might be a little confusing when both A and B are true, but there's nothing in or that states this can't be legit. Math deviates a little bit from our common usage of language sometimes. Now let's look at and. The statement A and B works pretty much as we'd expect. It's only true if both A and B are true. Next, we have not. And or are binary operators because they work with two inputs. Not is a unary operator because it only works with one input. Not just flips the bit, so to say. Whatever the input, it gives the opposite output. Now we have the fundamentals down, let's use them to build a new logical operation, exclusive OR. To start out, let's write how we want exclusive OR to work. The idea is to be true if A or B is true, but only if we have one or the other. If we have both, let's mark that as false. This is the common English language understanding of the word OR. Now let's talk about expressing this in fundamental operations. We want A or B and not A and B. This is a more complex statement to test, but we can still break it down and solve it. Let's solve the left-hand side first, and then the right side, then combine them. This method of breaking the statement down into columns and solving is perfectly good, and I use it all the time when I'm solving these sorts of problems. I need to step it out. I'm smart, but keeping track of these minor details is a waste of my brain power. Now we can see that both expressions have the same output for every single input, and we can conclude that they are equivalent. We denote this with this funny triple equal sign. Think of it like equal, but not just for numbers. Anyway, that's it for today. Hope you had fun, and I'll see you again soon.